Okay, so this time I have this circuit, and I want to come up with a state diagram. You might recognize this circuit. It was in one of the other review problems, but do it here. Notice this is a T flip-flop. It's a little bit different. This is 1, this is 0. First thing I want to do is come up with our next state expression. I have 2 flip-flops. That means I have 4 states. So my states are 0, 0, 0, 1, 1, 0, and 1, 1. And if I look at what these values are going to be, I'll call this one, this will be y1, this will be y0. So y1 equals, let's see, so y1 equals the OR of t and not y0. Okay, we have this OR gate, and that's the not of y0. So y1 equals t or not y0. Okay, so what does y0 equal? y0 equals, well, let's see, it's a T flip-flop. So I'll start by writing it like this. I know, because I don't actually know what the expression is for T flip-flop. I should, but I don't. So we have T and little y0 and big y0. 0, 0, 0, 1, 1, 0, 1, 1. So if t is 0, then this is unchanged. And if t is 1, then we toggle. So we get 0, 1, 1, 0. That is the exclusive OR. So y0 equals the exclusive OR of little y0 and t. Let's see, does that make sense? Let's see. Well, it is. Okay. All right, and now our output F is the AND of y0 and y1. So there's our next state expressions and our output expression. I'm going to check that. Let me just double check that. That looks right. That looks right. That looks right. Yep. Okay. All right. So now I want to do my state assign table. So I'll have my current state, and I'll have my next state, and I have, that's a B, not a T. Well, I'm going to keep calling it a T. T. So T equals 0, T equals 1, and output. Notice the output doesn't depend directly on the input, so this is a Moore machine. Okay, so, and this would be y1, y0, y1, y0, and this is F. Okay, so y1 is t or not y0. This is y1, y0. So when t is 0, it can't make this equal to 1. Only not y0 can make it equal to 1, and that would be 0. So when y0 is 0, the not of y0 would be 1, and then the or of that would, and 0 would be 1. So this would be 1 here and here, and 0 here and here. y0 is the exclusive OR of y0 and t. So exclusive OR is 1 when exactly one of them equals 1. If they're both 0, it's 0, and if they're both 1, it's 0. So t is 0, so they're both 0, so that's 0. Here, y0 is 1, and t is 0, so that's a 1. Here, they're both 0, so that's a 0. Here, y0 is 1, and t is 0, so that's a 1. Okay, now when t equals 1, 1 or anything is 1, so y1 will be 1 for all of these. y0, it's the exclusive OR of t and y0. So t is 1. So if t is 1, in order for this to be 1, y0 needs to be 0, because 1 or 0, 1 exclusive OR 0 is 1. 1 exclusive OR 1 is 0. Only one of them can be 1. So 1 exclusive OR 0 is 1. 1 exclusive OR 1 is 0. 1 exclusive OR 0 is 1. 1 exclusive OR 1 is 0. Now f is the AND of y1 and y0. So it'd be 0, 0, 0, 1. Okay, so now let's make a state table for this. Let's call these A, B, C, D. So current state. Next state. T equals 0, T equals 1. Output. A, B, C, D. A is 0, 0. That doesn't seem to show up anywhere else. Okay. B is 0, 1. That's here. Here. Okay, that's all for B. C is 1, 0. That's here and here. And here and here. And D is 1, 1. That's here and here. And our output is 0, 0, 0, 1. Now, if I wanted to do a state diagram, I would have my states. From A, if t is 0, I go to C. If t is 1, I go to D. From B, if t is 0, I stay at B. If t is 1, I go to C. From C, if t is 0, I stay at C. T is 1, I go to D. And from D, if t is 0, I go to B. And if t is 1, I go to C. And I can put my output on the states themselves because it's a Moore machine. So A is 0, B is 0, C is 0, and D is 1. Now I got this from, let's see, this question. That's a QR code. Where was it? From this one. So from the circuit starting Q1 equals 0, Q0 equals 0, show the sequence with B equals 1, 0, 1, 1, 0. So I'm starting from 0, 0, which is state A. So from state A, I don't know if I have that output or not. But then I get a 1, that would take me to state D. State D has an output of 1. Then I have a 0 that takes me to B, which has an output of 0. Then I have a 1 that takes me to C, that has an output of 0. Then I get another 1 that takes me to D, that has an output of 1. Then I get a 0 that takes me back to B, gets me a 0. Does that match what we had? 0 1 0 0 1 0 0 1 0 0 1 0. Wow, we did it another way. That's pretty cool. That was fun. I like that. Alright, upload time.